Hello, welcome to this video 2B-6, and we are going to talk about symbolic manipulation. We're going to revisit the properties of logarithms and using these properties to change the structure of a logarithmic expression. And we're also going to need to be familiar with our properties of exponents. So just a quick recap on the properties of exponents and on logarithms. Here we have the product property. For logarithms, if you're multiplying, you're going to go ahead and add those. For the quotient property, if you're dividing, you subtract those powers. And so I want you to see that connection along with the properties of logarithms, where we have the product property. If I'm adding logarithms, then we multiply the arguments. Oh, it's almost like they're switched or the inverse of each other. Okay, and for quotient, if I'm subtracting two logarithms, we end up dividing those arguments. So there is a connection there. The negative exponent property, remember that if you have a negative exponent, you can go ahead and take the reciprocal and make that power positive. And then we have the power property, where if you have one power raised to another, you end up multiplying those. So we will use exponent properties in this lesson, and we will also look at the properties of logarithms. I've already mentioned the product and the quotient property, which are very, very common. But again, a very, very important one is the power property. Remember, if you have a coefficient out in front, you can move that into the argument of the as the exponent of the argument. Now, we will have some definition-based properties that will activate, so just go ahead and refresh yourself with those. And then a rare one, but does pop up in this lesson, is the change of base property. Remember, if you need to change your base, you can make the logarithm any base you want. You just insert the new base, so log base b, whatever you want b to be, and then the argument in your numerator is your old argument, and the argument in your denominator is your old base. That's the change of base properties, okay? So generally when we are changing logarithms or consolidating or condensing, this is usually the order of these properties. You're going to use the power property first, then you're going to combine the logarithms using the product or quotient properties. You usually work from left to right, and then if you need to, use any definition-based properties, okay? Just a reminder, log base 10, we call that a common log, and log base e, we call that the natural log, ln of x. So let's go ahead and dive into today's lesson, where we're going to look at questions that pop up on FRQ 4. And FRQ 4 has a section where they want you to rewrite expressions, exponentials, logarithms, and so we're going to go ahead and look at some of those questions and how they appear, okay? All right, so example 1, they say the function f is given by f of x equals 2 times log base 3 of x minus 2 plus 5 times log base 3 of x plus 3 minus 3 times log base 3 of x. They say rewrite f of x as a single logarithm, one single logarithm, with base 3. F of x is a single logarithm, base 3, without negative exponents. Very important. No negative exponents in any part of your expression. And your result should be of the form log base 3 of expression. So your answer should look like this. So let's go ahead and let's do this. I have f of x, and I have 2 log base 3. Well, again, I'm going to take that coefficient, and I'm going to make it the power of my argument. Same with the 5 here. I'm going to make it log base 3 of x plus 3 to the power of 5 minus log base 3 of x to the power of 3. Okay, so all I did right in this was I just take these coefficients and I made them powers of the argument. That's your power property. Okay, next I'm going to go ahead and I'm going to condense this or consolidate these. These are all log base 3, so I can use my logarithmic properties, the product property, to combine these. So I have log base 3 of, I'm going to have x minus 2 squared times x plus 3 to the power of 5. Okay, and then I am subtracting this. So when I'm subtracting, I end up dividing. So I'm going to divide by x to the power of 3. And there you go. There is your log base 3 of one expression. Do you need to go ahead and multiply all this out? Nope. I do not have to go ahead and do that. Okay? So hopefully that kind of felt comfortable compared to what we did yesterday. All right, example 2. Same idea here. The function b is given by b of x equals 4 log base 10 of x minus 1 minus log base 10 of x minus 1 to the power 6 plus log base 10 of 4 minus x to the power 2. Rewrite b of x as a single logarithm base 10 without negative exponents in any part of the expression, and your result should be of the form log base 10 of the expression. So again, what I'm going to do here is I'm going to take b of x and I'm going to use the power property. So I have log of x minus 1 to the power of 4 minus log of x minus 1 to the power of 6 plus log base 10 of 4 minus x squared. Okay? So in this one, all I had to do was just move that 4 up. And I'm going to go ahead and condense these now. So what we get is we get log base 10 of, and what I want you to notice is that we have some expressions that are matching. I have x minus 1 to the power of 4 over x minus 1 to the power of 6. Those are going to consolidate. And then I'm adding this one, so this will multiply. So I have 4 minus x to the power of 2. And before I go ahead and write my final answer here, I want to cancel some stuff. So you can look at it as canceling, or again, when you're dividing, you're going to subtract these powers. So 4 minus 6, that would give you x minus 1 to the power of negative 2. But you don't want negative exponents. So what I'm going to do is I'm just going to take away 4 here, and that's going to leave me with 2 in the denominator, which is what we want, because I don't want negative exponents, according to the problem. So there you go. This is log base 10. Remember, this is a common log, base 10, written as a single expression. All right? All right. Let's go ahead. Practice one. Here's one for you guys. Please go ahead. Pause me. Try this one, and I'll show you the solution. Okay, d of x is equal to, first you're going to use the power property on these two coefficients of 2, so you move them up into the exponent of the argument, and you can see those there in red. And then we're going to consolidate these logarithms into a single expression. Because we're subtracting, we divide, so we get x plus 6 over x minus 1 squared. And then I'm subtracting again, so you're dividing that expression by x squared, which ends up multiplying with the denominator. So again, if you're subtracting, it's going to be in the denominator. If you're adding, it's going to be in the numerator. And so this is your answer. And just kind of like a note about standard form, we would expect to see that x to the power of 2 in the front. So that's kind of generally how you would see that answer written. Okay, but I think you'd be fine here at this stage. All right, hopefully you got that one correctly. Here you go. Here is round 2. Please go ahead, pause me. Try this example. Okay, another straightforward one. This is actually really simple, but it has lots of simplifications with fractions, which you might not like. First of all, did you use the power property on that 5 and that 1/2? Hopefully you did that, and then you go ahead and combine them. So hopefully at the very least you got to this stage, x to the 7th times x to the 5th divided by x to the power 1/2. We can consolidate our x to the 7th and x to the 5th by adding those to give us x to the power 12. And then what we have to do is we have to go ahead and subtract these. Now in order to subtract numbers, if you have a fraction, you have to have a common denominator. So I'm going to turn 12 into 24 over 2. And then we can take away 1 from that. So 24 over 2, take away 1/2 gives us 23 halves. So there is your answer. Okay, let's go ahead, let's look at a couple more examples. And we have one here that has natural logarithms. So they say the function j is given by j of x equals -8 natural log of x minus 2 minus 4 natural log of negative 2/3 natural log of x. Rewrite j of x as a single natural logarithm without exponents in any part of the expression. Your result should be of the form natural log of the expression. And what's kind of weird about this one, just out front here is I have a negative coefficient here. So I'm going to go ahead and I'm going to take that negative and I'm actually going to put that in the power. So it's going to be natural log of x minus 2 to the power of -8 minus natural log of x to the power of 4 minus natural log to the power of x to the power of 2/3. Okay, and you're saying, hey, why didn't you do that with these? Why didn't you take the negative with these coefficients? And I could. The effect will be exactly the same. Again, remember, if it's a negative, it's going to end up in the denominator, and you'll see that here. Even though I took this negative, right? Remember a negative exponent? I got to make that exponent positive, right? So where's it going to go? It's going to go in the denominator. So let's just go ahead and kind of see how this will shake out. So we have the natural log of x minus 2 to the power of negative 8 divided by x to the power of 4 times x to the power of 2/3. Okay, so there's all of that in one expression. And then what I see here is I see a negative exponent and I see some x's that I can go ahead and combine. So let's go ahead and do all that. I'm going to move that negative exponent down. So x minus 2, guess what? You're going down into the denominator. And now I have a positive exponent. We're happy, right? Because my instruction said without negative exponents. Then I have x to the 4th and x to the 2/3. Again, if you have a fraction, in order to combine these, I have to have a common denominator. So I'm going to multiply 4 times 3, which will give me 12. So this is 12/3. And now I can go ahead and add those. So really, nothing too difficult. I have x to the power of 14/3 times x minus 2 to the power of 8. Looks pretty wacky and weird, but pretty straightforward. Okay? All right, so here is one for you, a practice one. Pause me again, try this example. Okay, this one was a fun one, pretty straightforward. Maybe you're like, hey, this is really easy, but there was a slight curveball in the fact that when we go ahead after using the power rule first, the 5/4 to move it up, this 2x, this x here, does have an exponent of 1, and I want to combine it with this 5/4. So I'm going to change that x to the first into x to the power of 4/4. Now I can go ahead and I can combine those, right? So 4 plus 5 gives me 9. So here's your final answer, natural log of 2x to the power of 9/4 divided by 3 minus x. Again, when you add, you multiply the arguments. When you subtract, you divide. Okay? How'd you do? Did you get it? All right. Last example for this video that I'll have for you is the function d is given by d of x equals log base 4 of 6x plus 3 log of 16 of x, log base 16 of x. Rewrite d of x as a single logarithm base 4 without negative exponents in any part of the expression. Your result should be of the form log base 4 of the expression. Now, what's kind of different about this example is they want log base 4, which kind of jives with what we've been doing. Hey, I have log base 4, but you may freak out when you start to see this. Hey, I have log base 16. Oh my gosh. We're going to have to manipulate that or change that base somehow. So how are we going to go ahead and do this problem? The first thing I'm going to do is I'm going to still make sure that I move any powers into the exponent. So I have log base 4 of 6x plus log base 16 of x to the power of 3. Okay, now I want log base 4. So what I'm going to do is I'm going to change this log base 16. I'm going to change this log base 16 into log base 4. So I have log base 4 of 6x plus, now remember, how you do this is I just make a new logarithmic base. Log base 4 divided by log base 4. Hey, now I have log base 4. Wasn't that easy? The question is, what do I put inside of the arguments? That's the question. And we'll have to go back to your change of base property to remember this, but it's pretty simple. The argument stays the same in the numerator, so x to the power of 3, and your old base goes into the denominator. There you go. Now, this is not so difficult because I can go ahead and I can change log base 4 of 16 into a 2. So I have log base 4 of 6x plus log base 4 of x cubed divided by 2. Okay? Not so bad. But now, before I can go ahead and combine these logarithms, I have to get rid of this 2. So how do I get rid of this 2? Well, what I'm going to do is I'm going to rewrite this, and then hopefully you know what to do with it. So when you're dividing by 2, really what you're doing is you're multiplying by 1/2. Oh my gosh. So I have 1/2 of log base 4 of x to the power 3. And when I write it like this, what do I have to do this 1/2? See, you already know. I have to use the power rule. So I'm going to use the power rule here, and I get log base 4. Again, yes, again. I have to do it again. Plus log base 4 of x to the power 3 to the power 1/2. Which, oh my gosh, I myself ran out of room. So let's see. I'm going to go ahead. Let's condense this. So log base 4, since I'm adding, I am going to multiply these. So I have log base 4 of 6x times, this is going to be x to the power of 3/2. X to the power of 3/2. And we're at the same kind of issue we were before, right? Where I have to change this. This is a power of 1. So that's going to be 2 over 2. So here's our final answer. Oh, I know you guys are cursing me right now. If that's 2 over 2 plus 3, gives me 5. So 5/2. There's your final answer. Log base 4 of 6x to the power of 5/2. Okay, so that one did require a good amount of work because we had to change the base and then do the power rule again. Okay, here you go. Please pause me. Try this last practice problem for this video. Woo! Oh my gosh, this one had a lot. My hand got sore writing this. So the first curveball I want to talk about is the change of base. Hopefully you had power property, no problem, but this is log base 9. So we have to rewrite log base 9 as log base 3 of x divided by log base 3 of 9, which log base 3 of 9 is 2, and then so we end up bringing this 1/2 here up into the exponent. So hopefully you got that. No problem. You have x to the power of 1/2. But I do want to talk about the other curveball here, and that is the power property of the 3/4. That 3/4 is attached to the whole argument. That's 16x. And I left it alone all the way until I was done with the change of base issue. And I finally distributed it, right, to that coefficient and to the variable here. We have 16 to the power of 3/4 times x to the power of 3/4. And if you're unsure why, you're like, what? Why would you do that? Just ask yourself, what is 2x quantity squared? Well, isn't that 2x times 2x, which is 2 squared, times x squared? So when you have a coefficient, moral of the story is you distribute that power to the coefficient as well. So 16 to the power of 3/4, that just gives you 8. We can see this here. We have 8. And then we have to go ahead and combine our fractions here. I'm going to add these. So 3/4 plus 1/2. 1/2, that's 2/4. So 3/4 plus 2/4 gives us 5/4. All right, in this video, we went ahead and we looked at some FRQ4 questions that appear on the AP exam where we have to rewrite logarithmic expressions. Stay tuned, and there will be a video 2, which will specifically talk about multiple choice questions that involve this idea. All right, catch you in the next video. Take care.